Okay, so today we're going to talk about ethics in data science, which is a little bit of gear shifting from the coding and that sort of thing that we've been talking about. I have some links pulled up I'm going to show you, but we won't be on the computer or using R really at all. In some ways, it's more of a traditional lecture like I might give if we were in a regular class. So I know that most of you have thought about ethics at least a little bit, whether in the context of the major that you're in or just as a human on Earth, you think about how people make decisions, how people do things, how they go forward with things based off of what they have. Kind of three principles I'm going to talk about in this video, which really apply to ethics and statistics more generally, but also in data science, are who do I have to respect as part of this process of doing data analysis, data collection, data management? Correlation and causation, how they go together. And the third one is garbage in, garbage out. How can I ensure to the best of my ability that the data that I have is good? So I'm here on a web page. I link all these in the project. There's probably actually more links than you want to see. But here's one that kind of does walk through just a bunch of the steps. So you might want to read that as part of what we're doing. But I want to start talking about a book called The Bell Curve. And The Bell Curve came out in 1994. It was really one of the first books that really used sort of social science, big data in kind of a modern way. And unfortunately, it wasn't received very well because of some mistakes that were made in the analysis and some things that were going on there. So again, this is just a Wikipedia article about the bell curve. And its main claim is that, contrary to what people have sort of believed since the 1930s, this book really claimed that there might be a larger genetic component to intelligence than we thought. So there were just some people who weren't going to be successful. They were never going to be college ready. Some of their conclusions were pretty bold. For instance, depending on where in the country you are, some schools should focus more on getting people to go to college, while other schools should focus on getting people to go to trade schools or to just, get a non-college, non-higher education job where they can do the best they can. And this was contrary to most of what social science and education research had shown, which was that investing in schools, investing in K-12 education led to better results. And again, this book came out in the 90s, not the 50s. So in fact, these two guys sort of lost standing. One's a psychologist, one's a political scientist. And they sort of aren't cool in the communities anymore. And in a way, it kind of set the process of using big data analysis in social science research back because of some of the problems they have. So basically what they did is they looked at standardized test scores, both college entrance exams like SAT and ACT, mainly they looked at the SAT, as well as middle school and high school level state exams like the MAP tests you might have taken in Missouri, or the Iowa tests, or the California tests, or any of those various standardized tests. Now, you personally are probably pretty good at those tests, even if you don't love them, because you're at Truman, and Truman bases your admission, at least partially, on how you did on those tests. That said, you probably had friends who would say they didn't test well, or they just didn't like doing standardized tests. And even though they were plenty smart, and maybe as smart as you were, they weren't able to go to a school like Truman, or they looked for other options. Now, you might think that those tests are just kind of on their face, kind of goofy, and not very predictive at all. But it turns out there is some data that says that SAT and ACT scores are predictive of success in the first year at college, and that's a different story. But certainly schools like Truman use those a lot to figure out how they did it. So what they did was they were able to get some additional information from all the people, things like age, what school district they're in, income, a whole bunch of things. And then they were also able to get information on the people's parents. So how educated were their parents, what kind of jobs they had, that kind of thing. And you could imagine looking at all those things, it would be easy to look for correlations or regressions to find out which things show a high relationship with test scores. So what they found was that their parent scores were more predictive than almost anything else. And they go on to argue that because smart people like you and maybe me go to places like Truman or fancy schools, we tend to meet other people at fancy schools. We marry them, make babies who are also smart. and the people who don't do that tend to meet and marry people from those other backgrounds, and they tend to do that. And so they're actually arguing in this book that over time, the populations are actually becoming more separate. You're probably not surprised, especially those of you from Missouri, that race also plays into that. And they found that because many African Americans had low scores and their parents had low scores, they conclude that there's a measurable race difference, about 3 points on the ACT, which is, not nothing. And they wrote this book very boldly, very strongly. If you want to, you can go check it out at the library or find it online. I wouldn't recommend buying it because you would be then giving them money. But what's missing here is the idea of how the variables conflate and interact with each other. And we certainly know that people who are wealthy tend to live in areas with good schools. And in fact, a lot of people pick where they move based on the quality of the schools. We know that the price of houses varies with the quality of the school. So what you'd really like to see is some kind of designed experiment. And of course, that's hard to do. What we do have, what we call natural experiments, are cases where rich school districts bring in a sample of people who aren't so rich, or the neighborhoods are sort of mixed, or even where less wealthy people move to give their kids a chance. And one example that's been in the news lately is Alessandria Ocasio-Cortez, the new congresswoman from New York. She's not new, I guess, anymore. But she has this sort of rags to riches story where her mom literally moved to a school district that she couldn't really afford to live in just so her daughter could go to this better school. And it turns out it worked okay. She got into a good Ivy League school and is now a congresswoman, representing the area she grew up in, not the area where she went to school. So she would be an example that would support the idea that if everybody could go to a fancy school, that they would be better off as a result. Now, that's not the same as saying we should just pour a bunch of money into schools, because in fact, when that has happened, results have been pretty mixed because many of the schools aren't ready for the money, or they don't know what to do if they got a big influx of cash. So what they're really saying is that this is a more long-term change. And so, for instance, in states with high taxes, they tend to just have better performing students than people who live in low tax states. Now, again, if you're a student at Truman, you live in Missouri, which is famously a low tax state. And in Missouri, the main source of public school revenue is property taxes, which are done at a very local level. So what we find is that Missouri has one of the most widest ranges in terms of school performance. Our top schools are actually among the best in the country, and a lot of our less well-off schools, both urban and rural, have some real problems. And if you compare that to a high-tax state like Missouri or California, or not Missouri, Massachusetts or California, which are kind of famously high-tax states, their bottom is a lot higher. Their top students aren't actually any better than our top students, but again, that would be an issue in Missouri. Of course, I probably don't have to tell you that in Missouri, race is certainly an issue. We know that many areas, certainly in St. Louis and Kansas City, Springfield, are still quite segregated, not in the legal sense that they were in the 1950s, but because people didn't broadly move, we still see some of those effects today. Of course, the study of this is pretty complicated, and it's a different class, but it's important to see how we use data like this. If you look at the data or from the bell curve, or the kind of data that they use, they would actually say this 3-point difference between white students and African American students is real and important and meaningful, but it's conflated with so many other things. Anyway, the later part of the book is even worse when it talks about race and this idea of sociological evolution. And they have a whole theory about how former slaves had sort of the intelligence bred out of them. And anyway, it's a very painful book that I don't recommend reading. And so, this idea that we would just get a big data set, click some buttons, look at the p-value at the bottom and go, ooh, it's important, that looks cool, is one that's hard to say. In fact, this book has a very cool cover, and I actually think it's one of the coolest parts about the book. So this idea, though, that we can just turn the crank in R or in Excel or SPSS or Minitab or whatever, it's just not true. You have to apply your thinking. It's why whenever we use that data science Venn diagram, that idea of subject knowledge, content area knowledge is so important. Now, the main idea here is that we're not doing designed experiments. When you think about a health study, they take people who are roughly equal and they introduce a treatment. When you're using this existing data, so many things are going on at once, it's really hard to tease out what is important and what isn't important. You saw in that other video how easy it is to run a regression. You just hit LM and you put stuff in it, and you could do that all day and look for the ones that make a difference. Now, here, for instance, is one that does confuses people. Now, this is the carbon dioxide measurements from Mauna Loa Observatory. It's actually a telescope on the one of the dormant volcanoes in Hawaii, not the active ones that occasionally spew lava out. But there's a telescope there, and they put a weather station there. And what they did is they put a balloon up in the air, and they captured some of the air. And they do this every day, and they have since the 1950s. And Charles Keeling is the guy who famously started doing this. And I think it's hard to necessarily draw conclusions about what should be done about climate change. It's hard to make predictions about what's going to happen with temperature change. However, it's really hard to argue that this line doesn't go uphill, right? This is an uppy line, I would say, if we were in a regression class, and I'll probably say that again when we're in the regression section of this class. And, does this mean you need to put in squiggly light bulbs and drive an electric car? Well, that again needs to bring in other points. But the people who say that carbon dioxide isn't going up are simply just not telling the truth, because this goes up. You can see there's a periodic effect. And in fact, if we look at the data, this is actually the live web page from the place. If we look, there's actually a daily effect that around the middle of the day, it gets a little lower. And if we look over the course of the month, you can see it's a little bit harder to see. And if you look over the course of 1 year, you can actually see that dip and grow that you could see in the bigger chart, because this is a seasonal effect having to do with trees taking CO2 out of the air. If we look at it for 2 years, you can see that each of these lower bumps are going uphill. And again, if we go all the way back to 1950, whatever, 56, you can see that this trend has continued. There were some flattenings. There's actually a big volcano here, which made a flat spot. But in short, this is an uphill line. And compared to when I was born, when CO2 levels were in the mid 300s, it's now up over 400. That is pretty good data, well taken, but it's not an experiment. We don't have a second Earth that we could compare against, right? If we had 30 Earths and some of them didn't have industrial development, they didn't burn fossil fuels, we could really see what's going on, but that just can't happen. If we do look at some ice core samples, you can get some of these longer trend things. And if you look at the 10,000 year record, which is the one that Al Gore famously called a hockey stick, you can see how the CO2 levels in the last couple hundred years really have kind of spiked off the chart. Okay, so hearing about all this kind of abuse will make you say, well, maybe the whole field of data science is flawed. We can only do designed experiments, so screw all this. Well, it turns out that's wrong in both directions. First of all, it turns out there are some good things to do, which we'll have in the other video about how to do data science more ethically and better. But it's also true that you can have well-designed experiments without being ethical. Who is great at designed experiments? Nazis. And so, again, I'm not going to scroll too far down on this Wikipedia page because it gets pretty gross pretty quickly. But it turns out they did a ton of very well-designed controlled experiments on prisoners in concentration camps. So here they're not worried about consent. And in fact, many of our modern ideas about consent, which I'll talk about in a second, come as a result of the doctor's trial and the Nuremberg Code, which is part of the Geneva Convention about how we do designed experiments in a way that respect people's privacy and consent. Now you're probably saying, hey man, I'm just gonna be doing marketing at a company. I'm not doing drug trials. But these ideas still sort of plague us as a field, and they do make us really think about things. Just looking at the code of contents, again, I don't want to scroll down, you can see that there are a bunch of experiments, and the one I'm going to talk about, which is a Seawater Experiment, is one that we actually use the results of today, even though it was collected in a pretty horrific kind of way. So again, you've had a little bit of statistics, so you can imagine designing an experiment where we give people different amounts of seawater, right? We know that if you're stranded at sea, drinking seawater is bad, right? It makes you sick pretty quickly, and it's not a very good solution. But people have also noticed that you could dilute your fresh water with seawater to make it last longer. And so you could imagine that people were wondering how much should you mix? Should you mix 50-50? Should you mix 1 part in 10? And how would you do that? Well, as a statistician, as a scientist, it's pretty easy to imagine how we would do that experiment. What is harder is thinking that you would actually do that and you would give seawater to people until they got sick. That said, they were able to determine pretty conclusively that a mix of 3 parts freshwater to 1 part seawater long-term doesn't have any real consequences. So if you can get the salinity down below 2%, regular seawater is salinity about 3%, 3.5%. So if you can get that down below there, you can actually live off seawater for some time. And sailors, people, if you're ever stranded on an island with a volleyball and you're talking to it, mixing your freshwater to seawater can be a good solution. That said, no one would defend the kind of experiments they had. The same is true of malaria. We actually know a lot about how we treat malaria today. But if you think about how we do research designs today, we don't actually give people malaria so that we can see how the treatments work. But if you're a Nazi, that's exactly what you do. So there were even some experiments where they didn't share because they thought they were so horrific, the results were not worth the horrible things that happened. So they were embargoed or they're hidden. And seeing what is in this Wikipedia page, it's hard to imagine what isn't. Now, this might make you say, well, those are Nazis, right? Americans wouldn't do that. But in fact, Americans have several of our own bad stories. The Eugenics movement, which is one where in the early parts of the 20th century, the idea that people with bad genes shouldn't breed. I might say that the bell curve is sort of a direct consequence of the eugenics movement. And I think certain movements today talk about how genetic influence, we should encourage the people with good genes to breed and we should keep the people with bad genes from breeding. Now, eugenics has a special place at Truman because one of the stars of the eugenics movement, a guy named Harry Laughlin, is actually a graduate of our school a couple names ago. And his family was actually very influential in Kirksville. We actually also have all of his papers. If you go to the eugenicsarchive.org, which is in Cold Spring Harbor, New York, you can click on their archive. And what you'd find is we're actually one of their main sources. And even if you search for Kirksville, you'll find that we are actually the host of many of our records from there. And in particular, where Dr. Laughlin came from was he was interested in how the breeding of horses and cows has made better horses and cows in the last few centuries. And could those ideas be applied to people? Now, the movement itself is horrible. Again, I'll let you look at that at your own time if that's something you're interested in. But that study, the studies that they were doing today would never be allowed. And I think, again, if you read it, you feel pretty icky about that. Now, that said, statistics is just a tool. Data science is a set of tools. You have to use your own judgment and be wise in how you apply statistics, how you select statistics, how you implement them. And by you, I mean actual you, because you're going to be a person doing statistics or consuming the statistics that other people are there. And I'm not going to talk too much more about that, but Nazis and eugenics and syphilis are 100 years ago kind of things. But in data science, we have similar problems that still plague us today. It's a little bit different because typically the data is collected by someone else for some other purpose, and we're just using it for that. The company isn't collecting sales data just for you to do data on. They're collecting sales data because they need to deliver a product, they need to buy merchandise, they need to buy supplies so they can produce the product. They're keeping track of weather, not just so they can see long-term effects, but so they can give people real-time warnings about tornadoes or very short-term predictions about, do you need a hat tomorrow or an umbrella? A lot of the data we use is collected because you need to report to the government, you have to pay taxes, you have to report to shareholders. And so we're using and we're doing analysis on data that would have been existing anyway. The same is true for health data, all those kind of things. So these ideas are going to come back, and in the next video, I'm going to talk about how we in data science do much more specific things in order to get an ethical result and in order to stay on the good side of ethics as we do our analysis.